Picture this, a vast, swirling canvas of colors stretching across the cosmos, where stars are born and die in a dance of light and shadow. These are nebulae, nature's most breathtaking masterpieces, painted across the universe. But what if I told you that behind their stunning beauty lies a world of secrets waiting to be uncovered? Welcome to a journey through 25 of the most bizarre nebulae in space, where every cloud of gas and dust holds a story that challenges what we know about the universe. From the eerie remnants of dying stars to the chaotic nurseries where new ones are born, these cosmic wonders are more than just eye candy. They're windows into the mysteries of existence. So buckle up, because by the end of this video, you'll not only marvel at their beauty but also uncover the hidden truths that make these nebulae some of the most fascinating objects in the cosmos. Ready to explore? Let's dive in. Now, let's turn our gaze to one of the most famous and mysterious nebulae in the night sky, the Crab Nebula. This cosmic wonder has a history as dramatic as its appearance. Back in the year 1054, astronomers in ancient China and other parts of the world witnessed a brilliant new star lighting up the sky. What they were seeing was actually a supernova explosion, the violent death of a massive star. Today, the remnants of that explosion form the Crab Nebula, a swirling cloud of gas and dust that continues to captivate scientists and stargazers alike. At the heart of the Crab Nebula lies a pulsar, a rapidly spinning neutron star that's the dense core left behind after the supernova. This pulsar is no ordinary star. It spins around 30 times per second, sending out beams of radiation that sweep across space like a cosmic lighthouse. These beams include everything from radio waves to gamma rays, making the Crab Nebula one of the most energetic objects in the universe. But what's truly fascinating is how this pulsar powers the entire nebula, energizing the surrounding gas and creating its chaotic, almost ghostly appearance. The structure of the Crab Nebula is anything but orderly. Its filaments of gas twist and churn, forming intricate patterns that seem to defy logic. These chaotic swirls are a testament to the immense forces at play during the supernova explosion. Scientists study these patterns to learn more about how stars die and how their remains shape the cosmos. The Crab Nebula is like a cosmic crime scene, offering clues about the final moments of a star's life and the aftermath of its explosive end. But the Crab Nebula isn't just a relic of the past. It's also a laboratory for understanding some of the most extreme conditions in the universe. Its pulsar challenges our understanding of how neutron stars behave, and its chaotic structure raises questions about the physics of supernova remnants. What secrets does this eerie nebula still hold? As we continue to study it, the Crab Nebula reminds us that even in death, stars can teach us profound lessons about the universe. And speaking of lessons, our next stop takes us to a nebula that's all about the birth of stars, the Orion Nebula. Now, as we dig deeper into the mysteries of the Crab Nebula, we uncover questions that continue to baffle scientists. One of the most puzzling aspects is the behavior of its pulsar. Despite spinning at an astonishing rate of 30 times per second, this neutron star doesn't always follow the rules. Its radiation beams, which should be steady and predictable, sometimes flicker or spike in intensity without warning. This unpredictability has left researchers scratching their heads, wondering what hidden mechanisms are at play deep within this cosmic powerhouse. Another enigma lies in the Crab Nebula's magnetic fields. They are among the strongest ever observed, with intensities that defy our current understanding of physics. These magnetic fields are so powerful that they shape the nebula's chaotic structure, twisting its filaments of gas into intricate, almost artistic patterns. But how do these fields become so intense? Some theories suggest that the pulsar's rapid rotation and dense core amplify the magnetic forces, but the exact process remains a mystery. Scientists are using advanced telescopes and simulations to unravel this cosmic puzzle. hoping to shed light on the extreme conditions within neutron stars. Ongoing research into the Crab Nebula isn't just about solving these mysteries, it's also about expanding our knowledge of the universe. By studying this supernova remnant, scientists gain insights into how neutron stars form, how they evolve, and how they influence their surroundings. The Crab Nebula serves as a natural laboratory, offering a glimpse into the physics of extreme environments that we can't replicate on Earth. Each discovery brings us closer to understanding the life cycles of stars and the forces that shape the cosmos. As we continue to explore the Crab Nebula, it's clear that this cosmic wonder still has much to teach us. Its pulsars' erratic behavior and its intense magnetic fields are just two of the many secrets waiting to be unlocked. And while we may not have all the answers yet, the pursuit of these mysteries reminds us of the endless wonders that lie beyond our world. Next, we'll shift our focus to a nebula that's all about creation rather than destruction, the Orion Nebula, where stars are born in a dazzling display of cosmic artistry. Now, let's turn our gaze from the remnants of stellar destruction to a cosmic cradle of creation, the Orion Nebula. Located approximately 1,300 light-years from Earth, this dazzling region is one of the most studied and photographed nebulae in the night sky. Its vibrant hues of pink, red, and blue make it a favorite among both astronomers and stargazers, but its beauty is more than skin-deep. The Orion Nebula is a bustling stellar nursery where new stars are born in a spectacular display of cosmic artistry. At the heart of this nebula lies the Trapezium cluster, a group of massive young stars that illuminate the surrounding gas and dust with their intense radiation. These stars are incredibly hot and bright, some of them tens of times more massive than our Sun. Their energy causes the surrounding hydrogen gas to glow, creating the nebula's signature colors. But the Orion Nebula isn't just a pretty sight, it's a treasure trove of scientific discovery. By studying this region, astronomers have gained invaluable insights into how stars form, evolve, and shape their environments. One of the most fascinating aspects of the Orion Nebula is its sheer size. Stretching across 24 light-years, it's so vast that if you could see it in its entirety, it would appear 4 times the size of the full moon in our night sky. Yet, despite its immense scale, it's relatively close to us in cosmic terms, making it an ideal laboratory for studying star formation. Within its glowing clouds, astronomers have observed protoplanetary disks, rings of gas and dust swirling around young stars which may one day coalesce into planets. These discoveries have deepened our understanding of how solar systems, including our own, come into existence. The Orion Nebula also challenges our assumptions about star formation. While we often think of stars forming in isolation, this nebula reveals a more chaotic and dynamic process. Stars here are born in clusters, often influencing each other's development through gravitational interactions and radiation. Some stars even eject powerful jets of material as they form, carving intricate patterns into the surrounding gas. These phenomena remind us that the birth of stars is as complex and varied as the stars themselves. As we explore the Orion Nebula, we're not just witnessing the creation of stars, we're uncovering the building blocks of galaxies. This cosmic nursery offers a front-row seat to the processes that shape the universe, from the birth of stars to the formation of planetary systems. And while its vibrant colors and swirling clouds captivate our imaginations, its true significance lies in the secrets it holds about the origins of everything we see in the night sky. Next, we'll delve even deeper into the Orion Nebula's hidden chemistry and the surprising discoveries that continue to emerge from this stellar wonderland. Now, let's peel back another layer of the Orion Nebula's mysteries and uncover the hidden chemistry that makes this cosmic nursery so extraordinary. Beyond its stunning visuals, the Orion Nebula is a hotbed of complex chemical activity, teeming with organic molecules that hint at the building blocks of life itself. Yes, you heard that right. This glowing cloud of gas and dust isn't just creating stars. it's also brewing the ingredients for something even more profound. Deep within the nebula's swirling clouds, astronomers have detected molecules like water, carbon monoxide, and even simple organic compounds such as methanol and formaldehyde. These molecules are formed in the cold, dense regions of the nebula, where temperatures can drop to just a few degrees above absolute zero. It's in these frigid pockets that atoms and molecules come together, creating the raw materials for future stars, planets, and perhaps even life. The presence of these organic molecules challenges our understanding of star formation, suggesting that the process is far more intricate than we once thought. But the surprises don't stop there. The Orion Nebula also hosts a phenomenon known as hot cores, regions where newly formed stars heat their surroundings, triggering chemical reactions that produce even more complex molecules. These hot cores are like cosmic laboratories where the basic ingredients of life are cooked up under extreme conditions. Scientists believe that similar processes could have occurred in our own solar system billions of years ago, laying the groundwork for the planets and eventually life on Earth. What's truly mind-blowing is that the Orion Nebula isn't just a place where stars are born, it's also a potential birthplace for entire planetary systems. The protoplanetary disks observed within the nebula are rich in these organic molecules, suggesting that the seeds of life might be sown long before planets even form. This raises tantalizing questions. Could the Orion Nebula be a blueprint for how life emerges in the universe? And if so, how many other nebulae out there are following the same cosmic recipe? The Orion Nebula's chemistry also challenges our assumptions about the timeline of star and planet formation. Traditionally, we've thought of these processes as slow and steady, but the nebula's dynamic environment suggests otherwise. Stars here form in clusters, their radiation and stellar winds reshaping the surrounding gas and dust in real time. This chaotic interplay accelerates chemical reactions, creating a rich tapestry of molecules that might otherwise take millions of years to develop. It's a reminder that the universe is far more dynamic and interconnected than we often imagine. As we continue to study the Orion Nebula, we're not just learning about the birth of stars, we're uncovering clues about the origins of life itself. This cosmic cradle is a testament to the complexity and beauty of the universe, offering us a glimpse into the processes that shape everything from stars to planets to the very molecules that make life possible. Next, we'll journey to another stunning nebula where the death of a star has created a celestial masterpiece unlike any other. Now, let's turn our gaze to a celestial wonder that has captivated astronomers and stargazers alike, the Helix Nebula. Often referred to as the Eye of God due to its striking, almost hypnotic appearance, this nebula is a breathtaking example of a planetary nebula. But don't let the name fool you. Planetary nebulae have nothing to do with planets. Instead, they are the glowing remnants of stars like our Sun in the final stages of their life cycles. The Helix Nebula is located about 700 light-years from Earth, making it one of the closest planetary nebulae to us. Its intricate structure resembles a giant cosmic eye, with rings of glowing gas expanding outward in all directions. These rings are the outer layers of a dying star, shed into space as it exhausts its nuclear fuel. At the center of this celestial spectacle lies a white dwarf, the dense, hot core of the star that once was. This tiny but incredibly dense remnant is all that remains after the star's outer layers were ejected, creating the stunning nebula we see today. What makes the Helix Nebula so fascinating is its intricate structure. The glowing gases, primarily hydrogen and helium, are illuminated by the intense ultraviolet radiation from the white dwarf at its core. This radiation causes the gases to fluoresce, creating the vibrant colors that make the nebula so visually striking. But the Helix Nebula isn't just a pretty face, it's also a treasure trove of scientific insights. Its complex structure, including faint outer rings and delicate filaments, provides clues about the processes that occur during the final stages of a star's life. One of the most intriguing features of the Helix Nebula is the presence of comet-like knots scattered throughout its structure. These knots are dense clumps of gas and dust, shaped by the intense radiation and stellar winds from the central white dwarf. Each knot is roughly the size of our solar system, and they are thought to be the remnants of the star's outer layers, frozen in time as they drift away into space. These knots offer a glimpse into the chaotic and dynamic processes that shape planetary nebulae, revealing how the death of a star can create such intricate and beautiful structures. The Helix Nebula also serves as a reminder of our own sun's future. In about 5 billion years, our sun will exhaust its nuclear fuel and undergo a similar transformation, shedding its outer layers and leaving behind a white dwarf. The Helix Nebula gives us a preview of what that process might look like, offering a poignant reminder of the cyclical nature of the universe. As we marvel at its beauty, we're also witnessing a cosmic story of creation and destruction, where the end of one star's life paves the way for new beginnings. Next, we'll explore the Helix Nebula's unusual features in greater detail, uncovering the mysteries behind its peculiar knots and the forces that shape its glowing gases. Stay tuned as we dive deeper into this celestial masterpiece and the secrets it holds about the final chapters of a star's life. Now, let's take a closer look at one of the most puzzling features of the Helix Nebula, its peculiar knots of gas and dust. These comet-like structures scattered throughout the nebula are not just random formations, they hold vital clues about the final stages of a star's life. Each knot is a dense clump of material, roughly the size of our solar system, shaped by the intense radiation and stellar winds from the central white dwarf. But how did these knots form, and what do they tell us about the processes that occur as a star dies? One leading theory suggests that these knots are the remnants of the star's outer layers, ejected into space as it shed its material. As the star's core collapsed into a white dwarf, the outer layers were blown outward, creating a chaotic environment of gas and dust. Over time, the intense radiation from the white dwarf caused these materials to clump together, forming the dense knots we see today. These structures are not static. They are slowly being eroded by the relentless stellar winds, giving them their distinctive comet-like tails that stretch away from the central star. What makes these knots so fascinating is that they act as time capsules, preserving information about the conditions present during the star's final stages. By studying their composition and structure, scientists can piece together the sequence of events that led to the star's demise. For instance, the presence of certain molecules within the knots, such as carbon monoxide, suggests that the star underwent complex chemical processes as it died. These findings challenge our understanding of how stars evolve and shed their material, offering new insights into the life cycles of stars like our Sun. Another intriguing aspect of these knots is their role in the broader life cycle of the universe. As they drift away from the central star, they carry with them the raw materials needed to form new stars and planets. In a way, the death of one star becomes the birth of future cosmic structures. This cyclical process highlights the interconnectedness of the universe, where the end of one story marks the beginning of another. The Helix Nebula's knots also provide a unique opportunity to study the effects of extreme environments on gas and dust. The intense radiation and stellar winds from the white dwarf create conditions that are rarely observed elsewhere in the universe. By analyzing how these forces shape the knots, scientists can better understand the dynamics of planetary nebulae and the forces that drive their evolution. As we continue to explore the Helix Nebula, these knots remind us of the complexity and beauty of stellar death. They are not just remnants of a dying star, they are windows into the processes that shape the cosmos. By unraveling their mysteries, we gain a deeper appreciation for the intricate dance of creation and destruction that defines the universe. Next, we'll turn our attention to another cosmic marvel, the Orion Nebula, a star-forming region that showcases the birth of stars on an epic scale. Stay tuned as we journey deeper into the wonders of the cosmos. Now, let's shift our gaze to a cosmic spectacle that stands in stark contrast to the serene beauty of the Helix Nebula, the Carina Nebula. This colossal star-forming region, located about 7,500 light-years from Earth, is a bustling hub of stellar activity. It's home to some of the most massive and luminous stars ever discovered, including Eta Carinae, a hypergiant star that shines millions of times brighter than our Sun. The Carina Nebula is a place where the raw power of the universe is on full display, with towering pillars of gas and dust sculpted by the relentless forces of radiation and stellar winds. The landscape of the Carina Nebula is nothing short of dramatic. Imagine vast clouds of glowing gas stretching across hundreds of light-years, punctuated by dark, dense regions where new stars are being born. These pillars, often compared to the famous Pillars of Creation in the Eagle Nebula, are colossal structures that rise from the nebula's depths. They are not just static formations, they are dynamic, constantly reshaped by the intense radiation pouring out from the massive stars nearby. This radiation strips away layers of gas and dust, carving out intricate shapes and revealing the hidden stellar nurseries within. What makes the Carina Nebula truly extraordinary is the sheer scale of its star-forming activity. Here, stars are born in clusters, some of which contain dozens of massive stars packed into a relatively small area. The energy released by these young stars is staggering, heating the surrounding gas to extreme temperatures and causing it to glow in vivid hues of red, blue, and gold. This interplay of light and shadow creates a visual spectacle that has captivated astronomers and stargazers alike. But the Carina Nebula is more than just a feast for the eyes. It's a laboratory for studying the processes that govern star formation on a grand scale. The intense radiation from its massive stars not only shapes the nebula's structure, but also triggers the collapse of nearby gas clouds, leading to the birth of even more stars. This feedback loop, where stars both create and destroy their surroundings, is a key area of research for scientists trying to understand how galaxies evolve over time. One of the most fascinating aspects of the Carina Nebula is its role in the life cycle of stars. While the Helix Nebula showed us the end stages of a star's life, the Carina Nebula offers a glimpse into the chaotic beginnings. Here, stars are born in environments so extreme that they challenge our understanding of how such massive objects can form and survive. The nebula's massive stars, though dazzling, are also short-lived, destined to end their lives in spectacular supernova explosions that will further enrich the surrounding space with heavy elements. As we explore the Carina Nebula, we're reminded of the incredible diversity of the cosmos. From the delicate knots of the Helix Nebula to the towering pillars of Carina, each nebula tells a unique story about the forces that shape our universe. Next, we'll delve into the secrets of the Horsehead Nebula, a dark and enigmatic structure that has fascinated astronomers for generations. Stay with us as we continue our journey through the wonders of the night sky. Now, let's venture deeper into the heart of the Carina Nebula, where the universe's most extreme conditions come to life. This colossal star-forming region is not just a place of beauty, it's a battleground of cosmic forces. Violent stellar winds streaming from the nebula's massive stars at speeds of millions of kilometers per hour tear through the surrounding gas and dust. These winds are so powerful that they can strip away entire layers of material, reshaping the nebula's landscape in real time. Imagine standing in the midst of a hurricane, but one that spans light years and is fueled by the energy of stars millions of times more luminous than our Sun. Adding to the chaos are the remnants of past supernova scattered throughout the nebula. These explosive events, marking the deaths of massive stars, leave behind shockwaves that ripple through the surrounding space. These shockwaves compress gas clouds, triggering the birth of new stars even as they obliterate others. It's a cycle of creation and destruction on a scale that's almost impossible to comprehend. The Carina Nebula is a place where stars are born in the aftermath of stellar deaths, a testament to the interconnectedness of cosmic processes. What makes the Carina Nebula particularly fascinating is how it challenges our understanding of star formation. In most star-forming regions, stars are born in relatively calm environments, where gravity slowly pulls gas and dust together. But in the Carina Nebula, the rules are different. Here, the intense radiation and stellar winds create an environment so harsh that it defies conventional models. Stars form in the midst of chaos, their birth accelerated by the very forces that seem intent on tearing them apart. This raises intriguing questions. How do stars manage to form and survive in such extreme conditions? What mechanisms allow them to gather enough material to ignite, despite the relentless onslaught of radiation and wind? Scientists are particularly interested in the role of magnetic fields within the Carina Nebula. These invisible forces may act as a kind of cosmic shield, protecting nascent stars from the full brunt of the nebula's harsh environment. By studying these magnetic fields, researchers hope to uncover new insights into how stars can form in even the most hostile corners of the universe. The Carina Nebula, with its extreme conditions and relentless activity, serves as a natural laboratory for testing and refining our theories about star formation. As we reflect on the Carina Nebula's extreme environment, we're reminded of the resilience and adaptability of the cosmos. Even in the face of overwhelming forces, life, or in this case, starlight, finds a way to emerge. This nebula not only challenges our understanding, but also inspires us to rethink what we know about the universe. Next, we'll turn our attention to the Horsehead Nebula, a dark and mysterious structure that offers a stark contrast to the vibrant chaos of Carina. Join us as we continue to unravel the secrets of these cosmic wonders. Now, let's shift our gaze to a cosmic silhouette that has captured the imagination of astronomers and stargazers alike: the Horsehead Nebula. This iconic structure, located in the constellation Orion, is one of the most recognizable shapes in the night sky. Its dark, horsehead-like profile stands out dramatically against the glowing red background of emission nebula IC 434, creating a striking contrast that feels almost otherworldly. But the Horsehead Nebula is more than just a beautiful sight. It's a bustling stellar nursery where new stars are born amidst the swirling clouds of gas and dust. The Horsehead Nebula's distinctive shape is the result of a dense cloud of cold molecular gas and dust blocking the light from the glowing hydrogen gas behind it. This dark cloud, sculpted by the intense radiation from nearby stars, has been eroded over time, giving it its unique, curved appearance. It's like a cosmic sculpture shaped by the forces of nature over millions of years. The nebula's dark silhouette is a reminder of the delicate balance between creation and destruction in the universe, where even the most enduring structures are constantly evolving. What makes the Horsehead Nebula particularly fascinating is its role in star formation. Within its dense clouds, pockets of gas and dust collapse under their own gravity, igniting the birth of new stars. These young stars, still hidden within their dusty cocoons, will one day emerge to light up the surrounding space. The Horsehead Nebula offers astronomers a front-row seat to the early stages of star formation, providing valuable insights into how stars like our Sun come into existence. It's no wonder this nebula is a favorite among astronomers. It's a living laboratory where the mysteries of stellar birth are slowly being unraveled. But the Horsehead Nebula is also a reminder of the impermanence of cosmic structures. The same radiation that sculpts its shape is also slowly eroding it. Over time, the nebula will dissipate, its material scattered by the relentless forces of the universe. This ongoing process of change is a testament to the dynamic nature of the cosmos, where nothing remains the same forever. As we marvel at the Horsehead Nebula's beauty, we're also witnessing a fleeting moment in its long and complex history. Next, we'll delve deeper into the secrets of the Horsehead Nebula, exploring how its unique environment is shaping the stars within it and what its eventual disappearance will teach us about the life cycle of nebulae. Stay with us as we continue our journey through these cosmic wonders, uncovering the stories they hold and the lessons they offer about the universe we call home. Now, let's take a closer look at the forces shaping the Horsehead Nebula's future. This iconic structure, while breathtaking, is not eternal. The very radiation that gives it its dramatic silhouette is also slowly chipping away at its existence. Nearby stars, particularly the bright Sigma Orionis, bombard the nebula with intense ultraviolet light, stripping away its gas and dust over time. This process, known as photoevaporation, is gradually eroding the Horsehead Nebula, transforming its once dense clouds into diffuse materials scattered across space. It's a cosmic reminder that even the most enduring structures are subject to change. What does this mean for the Horsehead Nebula? Over the next few million years, its distinctive shape will fade, its material dispersed into the surrounding interstellar medium. But this isn't just a story of loss, it's a story of transformation. As the nebula dissipates, its gas and dust will contribute to the formation of new stars and planetary systems elsewhere in the galaxy. In a way, the Horsehead Nebula's eventual disappearance is part of a larger cycle of creation and renewal, where the end of one structure fuels the birth of another. This process offers astronomers a unique opportunity to study the life cycle of nebulae. By observing how the Horsehead Nebula evolves over time, scientists can better understand the mechanisms that drive the dispersal of gas and dust in star-forming regions. They can also gain insights into how these materials are recycled into new generations of stars and planets. The Horsehead Nebula, in its slow fade, becomes a living textbook, teaching us about the dynamic and interconnected nature of the universe. As we watch this cosmic sculpture dissolve, we're reminded of the impermanence of all things in the cosmos. Yet, even as the Horsehead Nebula fades, its legacy endures. The stars born within its clouds will continue to shine, and the lessons it offers about the life cycle of nebulae will remain invaluable. It's a poignant reminder that in the universe, endings are often just the beginning of something new. Next, we'll turn our attention to another stunning cosmic wonder, the Eagle Nebula, home to the famous pillars of creation. Join us as we explore how these towering structures are shaping the birth of stars and what their future holds in the ever-changing tapestry of the cosmos. Now, shifting our gaze to another marvel of the cosmos, we arrive at the Eagle Nebula, a star-forming region that has captured the imagination of astronomers and space enthusiasts alike. At the heart of this nebula lies one of the most iconic structures in the universe, the pillars of creation. These towering columns of gas and dust, stretching light years into space, are not just breathtaking to behold, they are also cosmic cradles nurturing the birth of new stars. The pillars of creation gained worldwide fame thanks to the Hubble Space Telescope, which captured their ethereal beauty in a series of stunning images. These photographs revealed intricate details of the pillars, showcasing their wispy tendrils and glowing edges illuminated by the intense radiation of nearby young stars. But beyond their visual splendor, these structures are dynamic and active, playing a crucial role in the process of star formation. Within the dense clouds of the pillars, pockets of gas collapse under their own gravity, heating up until they ignite into newborn stars. These young stars, still shrouded in their dusty cocoons, emit powerful radiation and stellar winds that sculpt the surrounding material, creating the intricate shapes we see. It's a delicate balance. While the stars are born from the pillars, their energy also erodes the very structures that gave them life. The Eagle Nebula, and particularly the pillars of creation, offers a unique window into the early stages of star formation. By studying these structures, astronomers can better understand how stars are born, how they influence their surroundings, and how they contribute to the evolution of galaxies. The Eagle Nebula is not just a static snapshot of the cosmos. It's a living, breathing laboratory where the forces of creation and destruction are constantly at play. As we marvel at the pillars of creation, we're reminded of the incredible scale and complexity of the universe. These towering structures, though immense, are just one small part of a much larger story, a story of birth, transformation, and the endless cycle of cosmic renewal. And as we continue our journey through the cosmos, the Eagle Nebula stands as a testament to the beauty and mystery of the universe, inviting us to explore its secrets further. Now, let's take a closer look at the fascinating processes unfolding within the Eagle Nebula, particularly within the pillars of creation. While these towering structures are celebrated for their role in birthing new stars, they are also under constant assault from the very stars they help create. The intense radiation and powerful stellar winds emitted by young stars are slowly but surely eroding the pillars, shaping their delicate forms and altering their future. As new stars ignite within the dense gas clouds, they unleash torrents of energy that push against the surrounding material. This process, known as photoevaporation, strips away the outer layers of the pillars, causing them to dissipate over time. While this might sound destructive, it's a natural part of the star-forming cycle. The erosion of the pillars doesn't just destroy, it also clears the way for future generations of stars to emerge, free from the constraints of their dusty cocoons. But what does this mean for the future of the Eagle Nebula? As the pillars continue to erode, the rate of star formation within them will gradually decline. However, the material being stripped away doesn't simply vanish. Instead, it disperses into the surrounding space, enriching the nebula with the raw ingredients needed for new stars and planetary systems. In this way, the Eagle Nebula is a cosmic recycler, transforming old structures into the building blocks of new ones. This ongoing interplay between creation and destruction highlights the dynamic nature of the universe. The pillars of creation, though iconic, are not permanent. They are a fleeting moment in the grand timeline of cosmic evolution, a reminder that even the most majestic structures in space are subject to change. Yet, their legacy lives on in the stars they've birthed and the material they've contributed to the nebula's ongoing story. By studying the Eagle Nebula, astronomers gain valuable insights into the life cycle of stars and the environments that shape them. It's a testament to the delicate balance of forces at work in the cosmos, where destruction paves the way for new beginnings. As we continue to explore the mysteries of the universe, the Eagle Nebula serves as a powerful reminder of the beauty and complexity of star formation, inviting us to ponder the endless cycles of creation that define our universe. Shifting our gaze to another cosmic marvel, let's explore the Ring Nebula, a stunning example of a planetary nebula. Unlike the chaotic beauty of the Eagle Nebula, the Ring Nebula presents a more symmetrical and serene appearance, resembling a glowing celestial donut suspended in the vastness of space. This iconic structure is the result of a dying star shedding its outer layers, creating a luminous shell of gas and dust that expands outward into the void. At the heart of the Ring Nebula lies a white dwarf, the remnant core of the star that once shone brightly. As the star exhausted its nuclear fuel, it began to collapse under its own gravity, triggering a series of dramatic events. The outer layers of the star were ejected into space, forming the intricate ring-like structure we see today. The intense ultraviolet radiation from the white dwarf illuminates these expelled gases, causing them to glow in vibrant hues of blue, green, and red. What makes the Ring Nebula particularly fascinating is its near-perfect symmetry. Unlike many other nebulae which exhibit irregular shapes, the Ring Nebula's circular form suggests a relatively stable and uniform ejection process. This symmetry provides astronomers with a unique opportunity to study the late stages of stellar evolution in detail. By analyzing the distribution of gases and the dynamics of the expanding shell, scientists can piece together the final chapters of a star's life. The Ring Nebula also serves as a cosmic time capsule, offering clues about the chemical composition of the star that created it. As the star shed its outer layers, it enriched the surrounding space with elements like carbon, nitrogen, and oxygen, ingredients essential for the formation of planets and ultimately life. This process highlights the interconnectedness of the universe, where the death of one star contributes to the birth of new worlds. Studying the Ring Nebula not only deepens our understanding of stellar death, but also provides insights into the future of our own Sun. In about 5 billion years, the Sun will undergo a similar transformation, shedding its outer layers and leaving behind a white dwarf surrounded by a glowing planetary nebula. The Ring Nebula, therefore, offers a glimpse into the distant future of our solar system, reminding us of the cyclical nature of the cosmos. As we marvel at the Ring Nebula's beauty, we're reminded that even in death, stars continue to shape the universe. Their remnants become the building blocks for new stars, planets, and perhaps even life itself. The Ring Nebula stands as a testament to the enduring legacy of stars, inviting us to ponder the profound connections that bind us to the cosmos. Now, let's take a closer look at the Ring Nebula's intricate structure, which reveals even more layers of cosmic artistry. While its iconic ring shape is the most striking feature, this nebula is far more complex than it first appears. Surrounding the bright central ring are faint outer rings, almost like ghostly echoes of the star's final act. These delicate structures, often overlooked in casual observations, provide critical clues about the processes that shaped the nebula. The faint outer rings are thought to be the result of earlier episodes of mass loss from the dying star. Before the dramatic ejection that formed the main ring, the star may have shed material in slower, more gradual bursts. These earlier layers expanded outward, creating the faint, concentric rings we see today. This layered structure acts like a cosmic timeline, preserving the history of the star's final millennia. Stellar winds also play a crucial role in shaping the Ring Nebula. As the star's core collapsed into a white dwarf, it unleashed powerful winds that pushed the ejected material outward. These winds sculpted the gas and dust into the nebula's distinctive shape, smoothing its edges and enhancing its symmetry. The interplay between the star's radiation and these winds continues to influence the nebula's evolution, causing it to expand and thin over time. Interestingly, the Ring Nebula's structure isn't perfectly uniform. Detailed observations reveal subtle asymmetries and knots within the gas, hinting at turbulent processes during the star's final stages. These irregularities challenge the notion of a perfectly smooth ejection and suggest that even in its death throes, the star experienced dynamic and chaotic events. By studying these intricate details, astronomers gain a deeper understanding of how planetary nebulae form and evolve. The Ring Nebula's complex structure serves as a natural laboratory, offering insights into the physics of stellar winds, the dynamics of gas expansion, and the chemical enrichment of space. It's a reminder that even the most serene-looking objects in the cosmos can harbor hidden layers of complexity. As we unravel the secrets of the Ring Nebula's structure, we're reminded of the delicate balance between order and chaos in the universe. Its faint outer rings and sculpted gases tell a story of transformation, resilience, and the enduring legacy of stars. Next, we'll turn our attention to another cosmic wonder, the Cat's Eye Nebula, where even more mysteries await. Now, shifting our gaze to another cosmic masterpiece, we encounter the Cat's Eye Nebula, a celestial wonder that captivates with its intricate concentric rings. This planetary nebula, located in the constellation Draco, is one of the most complex and visually stunning objects in the night sky. Its name comes from its striking resemblance to a feline's eye, with a bright central core surrounded by delicate, glowing rings that seem to ripple outward like waves in a cosmic pond. The Cat's Eye Nebula's formation is a story of stellar transformation. It began as a star similar to our Sun, which, after exhausting its nuclear fuel, began to shed its outer layers. Over thousands of years, these layers were ejected into space, creating the nebula's intricate structure. What makes the Cat's Eye particularly fascinating is the series of concentric rings that encircle its core. These rings are thought to be the result of periodic bursts of material ejected by the dying star at regular intervals, creating a layered effect that resembles the growth rings of a tree. At the heart of the cat's eye lies a hot, dense white dwarf, the remnant core of the original star. This white dwarf emits intense ultraviolet radiation, which lights up the surrounding gas, giving the nebula its vibrant glow. The interplay between the star's radiation and the ejected material has sculpted the nebula into its current form, with intricate knots and filaments that add to its complexity. One of the most intriguing aspects of the Cat's Eye Nebula is the mystery surrounding its concentric rings. While some theories suggest they were formed by the star's pulsations, others propose the influence of a companion star or magnetic fields. These rings provide a unique opportunity for astronomers to study the processes that occur during the final stages of a star's life, offering clues about how planetary nebulae evolve and interact with their surroundings. The Cat's Eye Nebula also plays a crucial role in our understanding of planetary nebulae as a whole. Its complex structure challenges the idea that these objects are simple, spherical shells of gas. Instead, it reveals the dynamic and often chaotic processes that shape them, from stellar winds to magnetic fields and even the influence of binary star systems. By studying the cat's eye, scientists gain valuable insights into the life cycles of stars and the ways in which they enrich the universe with heavy elements. As we marvel at the Cat's Eye Nebula's beauty and complexity, we're reminded of the intricate dance of creation and destruction that defines the cosmos. Its concentric rings and glowing gases tell a story of stellar death and rebirth, offering a glimpse into the forces that shape the universe. Next, we'll explore another enigmatic nebula, where even more secrets of the cosmos await discovery. Now, let's take a closer look at the mysterious rings of the Cat's Eye Nebula, a feature that continues to puzzle astronomers and spark curiosity. These concentric rings, glowing with ethereal beauty, are more than just a visual marvel. They hold clues to the complex processes that shaped this nebula. One leading theory suggests that the rings were formed by the dying star's pulsations. As the star neared the end of its life, it may have experienced periodic bursts of energy, ejecting material in waves that created the layered structure we see today. This process is similar to how ripples form on the surface of water when a stone is dropped, but on a cosmic scale. Another intriguing possibility is the influence of a binary star system. Some astronomers believe that the Cat's Eye Nebula's central star might have had a companion star orbiting it. As the primary star shed its outer layers, the gravitational pull of the companion star could have shaped the ejected material into rings. This interaction between the two stars would explain the precise, symmetrical arrangement of the rings, as well as the intricate knots and filaments that add to the nebula's complexity. The presence of a second star could also account for the periodic bursts of material, as the companion star's gravity might have triggered these ejections at regular intervals. Magnetic fields are another factor that could have played a role in shaping the Cat's Eye Nebula's rings. As the dying star's core collapsed into a white dwarf, its magnetic field may have intensified, channeling the ejected material into specific patterns. This magnetic influence could have created the concentric rings and the intricate structures within them, adding another layer of complexity to the nebula's formation. What makes the Cat's Eye Nebula so fascinating is that it challenges our understanding of planetary nebulae. Instead of being simple, spherical shells of gas, it reveals a dynamic and often chaotic process of stellar death. The rings, knots, and filaments tell a story of a star's final stages, shaped by forces like pulsations, binary interactions, and magnetic fields. By studying these features, astronomers gain valuable insights into how stars transform and enrich the universe with heavy elements, paving the way for new generations of stars and planets. As we unravel the mysteries of the Cat's Eye Nebula's rings, we're reminded of the intricate and interconnected nature of the cosmos. Each ring is a chapter in the story of a star's life, death, and legacy. Next, we'll turn our attention to another cosmic wonder, where even more secrets of the universe await discovery. Now, let's journey to a cosmic giant that dwarfs even the most spectacular nebulae we've explored so far, the Tarantula Nebula. Nestled within the Large Magellanic Cloud, a satellite galaxy of the Milky Way, the Tarantula Nebula is the largest and most active star-forming region in the entire local group of galaxies. Imagine a sprawling stellar nursery stretching over 650 light-years across, where stars are born in a frenzy of cosmic activity. This nebula is a powerhouse of creation, teeming with massive stars that burn brightly and live fast, shaping their surroundings with their intense radiation and stellar winds. At the heart of the Tarantula Nebula lies one of the most extreme environments in the known universe. Here, stars are born in clusters, some of which contain the most massive stars ever observed. These stellar behemoths, dozens of times more massive than our Sun, emit staggering amounts of ultraviolet radiation, ionizing the surrounding gas and causing it to glow with vibrant hues of red, blue, and green. The sheer energy radiating from these stars carves out vast cavities in the nebula, sculpting its structure and triggering further star formation in a self-perpetuating cycle of creation and destruction. But the Tarantula Nebula isn't just a place of beauty, it's also a laboratory for understanding the most extreme processes in the universe. The intense radiation from its massive stars creates shockwaves that compress nearby gas clouds, igniting the birth of new stars. At the same time, these same stars are destined to end their lives in spectacular supernova explosions, scattering heavy elements into space and enriching the interstellar medium for future generations of stars and planets. This dynamic interplay of creation and destruction makes the Tarantula Nebula a key site for studying the life cycle of stars and the evolution of galaxies. What truly sets the Tarantula Nebula apart is its sheer scale and activity. While most star-forming regions in our galaxy, like the Orion Nebula, are relatively modest in comparison, the Tarantula Nebula is a cosmic colossus. Its size and intensity make it a unique window into the processes that shaped the early universe when star formation was at its peak. By studying this nebula, astronomers gain insights into how the first stars and galaxies formed and how the universe evolved into the rich tapestry we see today. As we marvel at the Tarantula Nebula's grandeur, we're reminded of the incredible diversity and complexity of the cosmos. This nebula isn't just a star factory, it's a testament to the forces that drive the evolution of the universe itself. Next, we'll delve into another cosmic wonder where the secrets of stellar death and rebirth continue to unfold. Now, let's zoom in on one of the most dramatic aspects of the Tarantula Nebula, its role as a supernova factory. This nebula isn't just a birthplace for stars, it's also a stage for some of the most explosive events in the universe. The Tarantula Nebula boasts an unusually high rate of supernova, the cataclysmic explosions that mark the end of a massive star's life. These explosions are not just spectacular to observe, they are also crucial to our understanding of how the universe evolves. Within the Tarantula Nebula, massive stars, some weighing dozens of times more than our Sun, burn through their fuel at an astonishing rate. These stars live fast and die young, ending their lives in violent supernova explosions. When a supernova occurs, it releases an incredible amount of energy, outshining entire galaxies for a brief moment. But the impact of a supernova goes far beyond its flash of light. These explosions scatter heavy elements like iron, gold, and uranium into space, seeding the surrounding gas clouds with the building blocks for future stars, planets, and even life itself. The Tarantula Nebula's high supernova rate makes it a natural laboratory for studying these cosmic explosions. Astronomers have observed multiple supernovae within this nebula, providing valuable data on how massive stars die and how their death shaped their surroundings. Each supernova leaves behind a remnant, a shell of expanding gas and dust that interacts with the surrounding interstellar medium. These remnants are like cosmic fingerprints, revealing details about the star that exploded and the conditions in the nebula. One of the most fascinating aspects of the Tarantula Nebula's supernova is their role in triggering further star formation. When a supernova explodes, its shockwaves compress nearby gas clouds, creating dense regions where new stars can form. This process, known as triggered star formation, creates a cycle of birth and death that drives the evolution of the nebula. It's a reminder that even in destruction, there is creation, a theme that echoes throughout the cosmos. By studying the Tarantula Nebula's supernova, scientists gain insights into the life cycles of the most massive stars and the chemical enrichment of the universe. These explosions are not just endpoints, they're also beginnings, setting the stage for the next generation of stars and planets. As we continue to explore this cosmic powerhouse, we uncover more about the forces that shape our universe and our place within it. Next, we'll turn our gaze to another breathtaking nebula, where the secrets of stellar death and rebirth continue to unfold. Shifting our focus to another cosmic marvel, let's explore the Veil Nebula, a breathtaking supernova remnant that stretches across the night sky like a delicate tapestry of light and shadow. This nebula is the aftermath of a star that met its explosive end thousands of years ago, leaving behind a sprawling network of glowing filaments. These intricate tendrils of gas, illuminated by the energy of the explosion, create a mesmerizing display that has captivated astronomers and stargazers alike. The Veil Nebula is estimated to be around 8,000 years old, a testament to the enduring legacy of the supernova that birthed it. When the star exploded, it unleashed a shockwave that tore through the surrounding space, heating and compressing the interstellar gas into the intricate structures we see today. This explosion was so powerful that it would have been visible from Earth, lighting up the night sky with a brilliance rivaling the moon. Today, the remnants of that cataclysm stretch over 100 light-years, a vast and haunting reminder of the star's final moments. What makes the Veil Nebula particularly fascinating is its intricate structure. The filaments of gas, glowing in hues of red, blue, and green, are not just beautiful, they're also rich in scientific information. These filaments are made up of ionized gas, energized by the intense radiation from the supernova explosion. By studying their composition and movement, astronomers can piece together the story of the star's death and the forces that shaped its aftermath. The Veil Nebula serves as a cosmic laboratory, offering insights into the physics of supernova and the life cycles of stars. But the Veil Nebula isn't just a relic of the past, it's also a dynamic and evolving structure. The shockwaves from the explosion are still expanding, interacting with the surrounding interstellar medium and creating ripples of gas and dust. These interactions are shaping the nebula's future, influencing how it will continue to evolve over thousands of years. It's a vivid example of how the universe is constantly in motion, with even the most ancient events continuing to shape the cosmos. The beauty of the Veil Nebula lies not only in its visual splendor but also in the stories it tells. It's a window into the violent and transformative processes that drive the evolution of galaxies, including our own. As we gaze at its delicate filaments, we're reminded of the interconnectedness of all things in the universe, how the death of one star can give rise to new structures, new insights, and new mysteries waiting to be uncovered. Next, we'll delve deeper into the Veil Nebula's expanding shockwaves and the secrets they hold about the forces that shape our universe. Now, let's take a closer look at the Veil Nebula's expanding shockwaves, a phenomenon that continues to shape this cosmic masterpiece. These shockwaves, born from the supernova explosion thousands of years ago, are still rippling outward, carving their way through the surrounding interstellar material. Imagine throwing a stone into a still pond. The ripples spread out, distorting the water's surface. In much the same way, the shockwaves from the Veil Nebula's explosion are distorting and reshaping the gas and dust around it, creating a dynamic interplay of forces that astronomers are eager to study. What makes these shockwaves so intriguing is their ability to compress and heat the interstellar gas they encounter. As they expand, they push against the surrounding material, causing it to collapse and form dense regions. These regions can eventually become the birthplaces of new stars, linking the death of one star to the potential birth of others. It's a cosmic cycle of destruction and creation, where the end of one stellar life can sow the seeds for new beginnings. The shockwaves also carry with them a wealth of information about the original explosion. By analyzing their speed, structure, and interaction with the surrounding medium, scientists can reconstruct the energy and dynamics of the supernova event. For instance, the shockwave's speed can reveal how much energy was released during the explosion, while their shape can provide clues about the star's composition and the environment it exploded in. This makes the Veil Nebula not just a stunning visual spectacle, but also a valuable scientific tool for understanding the life and death of stars. Another fascinating aspect of these shockwaves is their role in enriching the interstellar medium. As they travel, they sweep up and redistribute elements forged in the heart of the exploding star, such as oxygen, carbon, and iron. These elements, essential for the formation of planets and life, are scattered across space, eventually becoming part of new stars, planets, and even living organisms. In a very real sense, the shockwaves from the Veil Nebula are helping to spread the building blocks of life throughout the galaxy. But the story doesn't end there. The shockwaves are also creating intricate patterns within the nebula itself, sculpting its delicate filaments and giving it the ethereal beauty we see today. These patterns are not static, they're constantly evolving as the shockwaves interact with different regions of gas and dust. Over time, this ongoing process will continue to alter the nebula's appearance, offering astronomers a front-row seat to the ever-changing nature of the cosmos. The Veil Nebula's shockwaves are a vivid reminder that the universe is a place of constant motion and transformation. They show us how the echoes of a single event can ripple across space and time, influencing the cosmos in ways we're only beginning to understand. As we continue to study these shockwaves, we uncover not just the secrets of the Veil Nebula, but also the broader story of how stars live, die, and shape the universe around them. Next, we'll turn our attention to another cosmic wonder, the Lagoon Nebula, where the birth of stars paints a vibrant picture of creation in the cosmos. Now, shifting our gaze to another cosmic marvel, let's explore the Lagoon Nebula, a dazzling star-forming region that paints a vivid picture of creation in the cosmos. Located about 4,000 light-years away in the constellation Sagittarius, the Lagoon Nebula is a sprawling cloud of glowing gas and dark dust lanes, illuminated by the intense radiation of its young, massive stars. This nebula is a stellar nursery where the raw materials of the universe come together to birth new stars, offering us a front-row seat to the processes that shape the cosmos. At the heart of the Lagoon Nebula lies a cluster of young, hot stars known as NGC 6530. These stars, some only a few million years old, are incredibly bright and energetic, flooding the surrounding gas with ultraviolet light. This radiation ionizes the hydrogen gas, causing it to glow in vibrant shades of red and pink, while the dark dust lanes create striking contrasts, giving the nebula its distinctive, almost painterly appearance. It's a dynamic environment where the forces of gravity, radiation, and stellar winds are constantly at work, sculpting the nebula into its current form. One of the most fascinating features of the Lagoon Nebula is its massive pillars of gas and dust, reminiscent of the famous pillars of creation in the Eagle Nebula. These towering structures are the birthplaces of new stars, as the dense material within them collapses under its own gravity, igniting the fusion processes that light up young stars. Over time, the intense radiation from nearby stars erodes these pillars, carving them into intricate shapes and revealing the newborn stars hidden within. It's a delicate balance between creation and destruction, where the very forces that give life to stars also shape their surroundings. The Lagoon Nebula is also home to a phenomenon known as a Bok globule, a dense, dark cloud of gas and dust that serves as a cocoon for forming stars. These globules are some of the coldest and most isolated regions in the nebula, shielding the nascent stars within from the harsh radiation of their neighbors. As these stars grow and begin to emit their own light, they will eventually break free from their dusty shells, adding to the nebula's population of young stars and continuing the cycle of stellar birth and evolution. What makes the Lagoon Nebula particularly intriguing is its accessibility. Unlike some nebulae that require powerful telescopes to observe, the Lagoon Nebula is visible to the naked eye under dark skies, appearing as a faint smudge of light. Through binoculars or a small telescope, its intricate details come to life, offering amateur astronomers a glimpse into the processes that shape our galaxy. It's a reminder that the wonders of the universe are not always hidden in the distant reaches of space. Sometimes they're right there, waiting to be discovered. As we marvel at the Lagoon Nebula's beauty, we're also reminded of its scientific significance. By studying this star-forming region, astronomers gain insights into the early stages of stellar evolution, the role of radiation in shaping nebulae, and the complex interplay of forces that govern the cosmos. The Lagoon Nebula is more than just a stunning sight. It's a laboratory for understanding the birth of stars and the processes that drive the evolution of galaxies. Next, we'll delve into the Trifid Nebula, where the interplay of light and dark creates a cosmic masterpiece unlike any other. Now, let's turn our attention to the powerful stellar winds that sweep through the Lagoon Nebula, shaping its structure and influencing its evolution. These winds, generated by the intense radiation and energy output of the nebula's young, massive stars, are a driving force behind the dramatic changes we observe in this cosmic nursery. As these stars burn brightly, they emit streams of charged particles that race outward at incredible speeds, colliding with the surrounding gas and dust. This interaction creates a dynamic environment where the forces of creation and destruction are constantly at play. The stellar winds within the Lagoon Nebula are particularly intense due to the presence of stars like Herschel 36, one of the brightest and most massive stars in the region. This star alone emits radiation and winds so powerful that they carve out vast cavities in the surrounding gas, pushing it outward and creating shockwaves that ripple through the nebula. These shockwaves compress the gas, triggering the formation of new stars in their wake. It's a fascinating cycle. Stellar winds from one generation of stars help birth the next, ensuring the nebula remains a vibrant hub of activity. But these winds don't just create, they also destroy. As they sweep through the nebula, they erode the delicate structures of gas and dust, including the towering pillars that are home to forming stars. Over time, the relentless pressure of the winds can strip away the outer layers of these pillars, exposing the young stars within and altering the nebula's appearance. This process, while destructive, is also a vital part of the nebula's evolution, as it redistributes material and influences the conditions for future star formation. The impact of stellar winds extends beyond the visible structures of the Lagoon Nebula. They also play a crucial role in heating the surrounding gas, increasing its temperature and pressure. This heating can prevent further star formation in some areas, as the gas becomes too hot and turbulent to collapse under gravity. In other regions, however, the winds can trigger the collapse of dense clouds, setting the stage for new stars to ignite. It's a delicate balance where the same forces that hinder star formation in one area can promote it in another. Studying the stellar winds of the Lagoon Nebula provides astronomers with valuable insights into the life cycle of stars and the evolution of nebulae. By observing how these winds interact with the surrounding material, scientists can better understand the processes that govern star formation and the ways in which massive stars shape their environments. The Lagoon Nebula, with its intense winds and vibrant activity, serves as a natural laboratory for exploring these phenomena, offering a glimpse into the forces that drive the cosmos. As we continue our journey through the wonders of the universe, the Lagoon Nebula reminds us of the intricate interplay between creation and destruction and the powerful forces that shape the cosmos. Next, we'll explore the Crab Nebula, where light and shadow come together to create a celestial masterpiece unlike any other. Now, shifting our gaze to another cosmic wonder, we arrive at the Crab Nebula, a stunning celestial object that stands out for its unique three-lobed appearance. Located in the constellation Sagittarius, this nebula is a fascinating blend of three distinct types of nebulae: emission, reflection, and dark, each contributing to its striking visual complexity. The Crab Nebula is a cosmic tapestry where light and shadow intertwine, offering astronomers a rare opportunity to study the diverse processes at work in the universe. The emission portion of the Crab Nebula glows with a vivid red hue, caused by the ionization of hydrogen gas by the intense ultraviolet light from nearby young hot stars. This region is a hotbed of star formation, where massive stars are born and radiate energy that lights up the surrounding gas. In contrast, the reflection nebula component shines with a cooler, bluish tint as starlight scatters off fine dust particles, creating a softer, more ethereal glow. Together, these two regions paint a breathtaking picture of cosmic activity. Adding to its complexity, the Crab Nebula is also home to dark nebulae, dense clouds of gas and dust that block the light from behind them, creating dramatic, shadowy lanes that divide the nebula into its iconic three lobes. These dark regions are not just voids, they are the birthplaces of future stars where gravity slowly pulls material together to form new stellar systems. The interplay of light and shadow in the Crab Nebula makes it a visual masterpiece and a valuable subject for scientific study. What makes the Crab Nebula particularly important is its role in helping astronomers understand the different types of nebulae and their interactions. By observing how emission, reflection, and dark nebulae coexist and influence one another, scientists can gain insights into the life cycles of stars and the evolution of stellar nurseries. The Crab Nebula serves as a natural laboratory, offering a snapshot of the dynamic processes that shape the cosmos. As we marvel at the Crab Nebula's beauty, we're reminded of the intricate balance between light and darkness, creation and obscurity that defines the universe. Next, we'll journey to the Rosette Nebula, where a cluster of young stars illuminates a cosmic flower in the depths of space. Now, let's take a closer look at the Crab Nebula's unique composition, a cosmic cocktail of gas, dust, and young stars that reveals the incredible diversity of nebulae. This celestial object is more than just a visual marvel. It's a dynamic environment where multiple processes unfold simultaneously, offering a glimpse into the varied ways nebulae can form and evolve. At the heart of the Crab Nebula lies a bustling stellar nursery, where young, massive stars are born amidst swirling clouds of gas and dust. These stars, still in their infancy, emit powerful radiation that ionizes the surrounding hydrogen gas, creating the nebula's signature red glow. This emission region is a testament to the raw energy of star formation, where the birth of new stars lights up the cosmos, but the Crab Nebula doesn't stop there. Its reflection nebula component adds another layer of intrigue, with starlight bouncing off fine dust particles to create a soft, bluish glow. This interplay of light and dust showcases how different wavelengths of light interact with cosmic materials, painting a vivid picture of the nebula's structure. It's a reminder that nebulae are not just static clouds, they are dynamic, ever-changing environments. Adding to this complexity are the dark nebulae, dense regions of gas and dust that block the light from behind them, carving out the nebula's iconic three-lobed shape. These dark lanes are more than just shadows, they are the cradles of future stars. Within these dense clouds, gravity slowly pulls material together, setting the stage for the next generation of stellar systems. The Crab Nebula's dark regions highlight the delicate balance between creation and obscurity, where the seeds of new stars are sown in the cosmic darkness. What makes the Crab Nebula truly special is its ability to showcase the diversity of nebulae in one place. Here we see emission, reflection, and dark nebulae coexisting and influencing one another, offering astronomers a rare opportunity to study these processes side by side. This unique mix provides valuable insights into how stars form, evolve, and shape their surroundings, making the Crab Nebula a natural laboratory for understanding the cosmos. As we reflect on the Crab Nebula's intricate composition, we're reminded of the incredible variety found in the universe. Each nebula tells a different story, and the Crab Nebula, with its blend of light, shadow, and stellar activity, is a shining example of this cosmic diversity. Next, we'll turn our attention to the Rosette Nebula, where a cluster of young stars illuminates a cosmic flower in the depths of space. Now, let's shift our gaze to the Rosette Nebula, a breathtaking cosmic bloom located in the constellation Monoceros. This massive star-forming region, spanning over 100 light-years, is a stunning example of nature's artistry, resembling a delicate flower unfurling in the depths of space. At its core lies a cluster of young, hot stars, whose intense radiation carves out the nebula's intricate structure and illuminates its surrounding gas clouds. The Rosette Nebula's flower-like appearance is no accident. The powerful stellar winds and radiation from its central star cluster push against the surrounding gas and dust, sculpting the nebula into its iconic shape. This process, known as stellar feedback, is a key driver of the nebula's evolution. As the young stars continue to grow and emit energy, they create cavities within the gas, giving the nebula its petal-like formations. It's a dynamic interplay between creation and destruction, where the birth of stars shapes the very environment that birthed them. Within the Rosette Nebula, the star cluster NGC 2244 takes center stage. This group of young stars, some of which are only a few million years old, is a hotbed of stellar activity. Their combined energy heats the surrounding hydrogen gas, causing it to glow with a vibrant red hue. This emission nebula component is a hallmark of star-forming regions, where the raw power of stellar birth lights up the cosmos. But the Rosette Nebula isn't just about light, it's also about the shadows. Dark lanes of dust weave through the glowing gas, adding depth and texture to the nebula's structure. These dense regions are the birthplaces of future stars, where gravity slowly pulls material together, setting the stage for the next generation of stellar systems. What makes the Rosette Nebula particularly fascinating is its role in teaching us about the life cycle of stars and their impact on their surroundings. The nebula's young stars are not just passive inhabitants, they are active participants shaping the environment that will eventually give rise to new stars and planetary systems. This ongoing cycle of creation and transformation is a reminder of the interconnectedness of the cosmos, where every star plays a part in the grand tapestry of the universe. As we marvel at the Rosette Nebula's beauty, we're reminded of the delicate balance between light and shadow, creation and destruction that defines the cosmos. Next, we'll explore how the young stars within this nebula continue to shape its environment, revealing even more about the processes that drive the evolution of star-forming regions. Now, let's take a closer look at how the young stars within the Rosette Nebula are actively shaping their cosmic surroundings. These stars, born from the very gas and dust they now illuminate, are not just passive observers, they are powerful forces of change. Through their intense radiation and fierce stellar winds, they are sculpting the nebula, carving out cavities and influencing the future of star formation in this region. The radiation emitted by the young stars in the Rosette Nebula is a double-edged sword. On one hand, it energizes the surrounding hydrogen gas, causing it to glow with that signature red hue we associate with emission nebulae. On the other hand, this same radiation exerts pressure on the gas and dust, pushing it outward and creating vast, hollowed-out regions. These cavities, often referred to as bubbles, are a direct result of the star's energy, and they play a crucial role in determining how the nebula evolves over time. But radiation isn't the only force at work here. The stellar winds from these young stars are equally impactful. These winds, composed of charged particles streaming outward at incredible speeds, collide with the surrounding material, compressing it and triggering new waves of star formation. It's a fascinating cycle. Stars are born, they shape their environment, and in doing so, they create the conditions for the next generation of stars to emerge. This process, known as stellar feedback, is a key driver of the nebula's dynamic structure. One of the most striking examples of this feedback can be seen in the way the Rosette Nebula's central star cluster, NGC 2244, interacts with its surroundings. The combined energy from these stars has created a massive cavity surrounded by walls of dense gas and dust. These walls, illuminated by the star's light, form the nebula's iconic petal-like structures. But they're more than just beautiful, they're also the sites of ongoing star formation. As the stellar winds and radiation continue to compress the gas, new stars are born within these dense regions, perpetuating the cycle of creation and transformation. What's truly remarkable about the Rosette Nebula is how it demonstrates the interconnectedness of cosmic processes. The stars within it are not isolated entities. They are part of a larger system where their actions have far-reaching consequences. By studying the Rosette Nebula, astronomers gain valuable insights into how stars influence their environments and how these environments, in turn, shape the stars that form within them. It's a delicate dance of forces, one that highlights the intricate balance between creation and destruction in the universe. As we continue our journey through the cosmos, the Rosette Nebula serves as a vivid reminder of the power and beauty of stellar feedback. Next, we'll turn our attention to another cosmic wonder, the Dumbbell Nebula, where we'll explore the final stages of a star's life and the stunning structures it leaves behind. Now, shifting our gaze to another cosmic marvel, we arrive at the Dumbbell Nebula, a breathtaking example of a planetary nebula. Known for its distinctive hourglass shape, this celestial object is one of the brightest and most studied of its kind. Located approximately 1,200 light-years away in the constellation Vulpecula, the Dumbbell Nebula offers a stunning glimpse into the final stages of a star's life. The Dumbbell Nebula, also catalogued as Messier 27, was formed when a sun-like star exhausted its nuclear fuel and began to shed its outer layers. As the star's core collapsed, it released intense ultraviolet radiation, causing the ejected material to glow brightly. This process created the nebula's intricate structure, with its two symmetrical lobes of gas expanding outward. At the center lies the remnant of the original star, now a dense, hot white dwarf. This tiny but incredibly dense object is the engine that powers the nebula's glow, illuminating the surrounding gas with its radiation. What makes the Dumbbell Nebula particularly fascinating is its role in helping astronomers understand stellar evolution. Planetary nebulae like this one represent a critical phase in the life cycle of stars, marking the transition from a dying star to a white dwarf. By studying the Dumbbell Nebula, scientists can learn about the processes that occur as stars like our Sun approach the end of their lives. The nebula's structure, with its expanding shells of gas, provides clues about how stars lose mass and how this material is recycled into the interstellar medium, contributing to the formation of future stars and planets. The Dumbbell Nebula's brightness and relatively close proximity to Earth make it an ideal target for both amateur and professional astronomers. Its vivid colors and intricate details, captured in stunning images, reveal the delicate balance of forces at play during this stage of stellar evolution. The nebula's lobes, composed of ionized gas, are expanding at a rate of about 31 kilometers per second, a testament to the powerful forces unleashed during the star's final act. As we marvel at the Dumbbell Nebula, we're reminded of the transient nature of stars and the beauty that can emerge from their demise. This cosmic object not only captivates us with its visual splendor, but also deepens our understanding of the universe's grand cycles. Next, we'll delve deeper into the Dumbbell Nebula's expanding shells and uncover what they reveal about the final stages of a star's life. Now, let's take a closer look at the Dumbbell Nebula's expanding shells of gas, which hold fascinating clues about the final stages of a star's life. These shells, composed of ionized gas, are not just remnants of the star's outer layers, but also a dynamic record of its final moments. As the star shed its material, it created multiple layers of gas, each expanding outward at incredible speeds. The outermost layers, moving at about 31 kilometers per second, are the most visible, glowing brightly under the intense radiation from the central white dwarf. What makes these expanding shells so intriguing is the way they reveal the star's history. Each layer represents a different phase of the star's death, offering a timeline of its final transformation. The inner shells, closer to the white dwarf, are denser and hotter, while the outer layers are more diffuse and cooler. This layered structure allows astronomers to study how the star lost its mass over time and how the ejected material interacted with the surrounding space. It's like peeling back the layers of a cosmic onion, each one telling a unique part of the story. The Dumbbell Nebula's shells also provide insights into the forces at play during a star's final act. The powerful stellar winds and radiation from the white dwarf continue to shape the nebula, pushing the gas outward and sculpting its distinctive hourglass shape. Over time, these forces will cause the shells to disperse further, eventually blending into the interstellar medium. This process is a crucial part of the cosmic cycle, as the material from dying stars becomes the building blocks for new stars and planets. One of the most remarkable aspects of the Dumbbell Nebula's expanding shells is their role in understanding the fate of stars like our Sun. By studying the rate at which the shells are expanding and the composition of the gas, scientists can predict how our own star might behave in its final stages. The Dumbbell Nebula serves as a cosmic laboratory, offering a glimpse into the future of stellar evolution and the intricate processes that govern the life and death of stars. As we explore these expanding shells, we're reminded of the delicate balance between creation and destruction in the universe. The Dumbbell Nebula's beauty lies not just in its appearance, but in the profound lessons it teaches us about the cycles of stellar life. Next, we'll turn our attention to another cosmic wonder, the Cat's Eye Nebula, and uncover the secrets behind its mysterious rings. As we come to the end of our journey through these 25 bizarre nebulae, it's impossible not to be struck by their breathtaking beauty and the profound mysteries they hold. From the chaotic remnants of supernova like the Crab Nebula to the delicate, glowing rings of the Cat's Eye Nebula, each of these cosmic wonders tells a unique story about the life and death of stars. They are not just stunning to behold, but also invaluable to science, offering clues about stellar evolution, the birth of new stars, and even the origins of life itself. These nebulae remind us that the universe is a place of endless wonder, where creation and destruction are intertwined in a delicate cosmic dance. They challenge us to look beyond our world and ponder the vastness of space, filled with secrets waiting to be uncovered. Whether it's the towering pillars of the Eagle Nebula or the intricate filaments of the Veil Nebula, each one invites us to explore, question, and marvel at the mysteries of the cosmos. So, the next time you gaze up at the night sky, remember that you're looking at more than just stars. You're witnessing the birthplaces of new worlds, the final breaths of dying stars, and the raw materials that make up everything we know. The universe is vast, mysterious, and endlessly fascinating, and these nebulae are just a glimpse of what's out there. If you've enjoyed this journey through the cosmos, don't forget to hit that subscribe button and ring the notification bell so you never miss out on more space mysteries. And let us know in the comments which of these nebulae captivated you the most. Until next time, keep exploring, keep wondering, and keep looking up at the stars. The universe has so much more to show us.